Now, this one is just like a review of our last class, though this is not what we actually would discuss in depth. But we are coming from this angle because it is a branch. What we actually consider falls under this branch of mathematics. We what? Number based. But the branch we are looking at is what? Number theory. There are still some other concepts we look under this. Talking about divisibility, Fermat, little theorem. It has more application when it comes to encryption. So for the number theory, I said what? It is a branch of what? Mathematics that deals with properties, likewise the relationship of integers. Because if you say numbers, we have varieties of numbers. Numbers can be classified as natural numbers, irrational numbers, rational, complex, etc. So we have real numbers as what? A set of numbers. But our main focus here is what? Integers. And I try to what? To demonstrate, or I give an example of an integer. Integer, we use this symbol Z to denote that set. So that set actually consists of whole number, positive whole number, zero, and negative whole number. Those are the what? The constituents of that word set. So now, back to this. So they are talking about the properties and the relationship. So we are talking about the what is it called? Divisibility. So what I actually mean by divisibility is that, for instance, if you have a number now, so there are some certain number that can divide in another number without a remainder. Our assumption is the remainder will be what? Zero. So for instance now, if I should have 4, for instance now, I have 12 for instance. 12 is a number. So looking at this 12, there are some certain number that can divide what? 12. You understand? So this 12 is divisible by 1, is divisible by 2, 3, 4, likewise the 12 itself. We have 6 also. Time for that. So all these numbers, they are numbers that can divide what? 12. You understand? So the divisibility is just talking about how are we going to know that this number can divide this, or this number cannot divide this number. So there are some more rules behind that. Like for instance now, if a number is given to me and I want to know whether what 2 can divide what such number, and if a number ends with an even number, so that means 2 can divide the number. So what did I mean by what? A number ending with what? Even number. So let us come from this angle. What is what? Even number. Because number theory is talking about everything about number. And for this cryptography of a thing that we want to look at, we have one number that is very crucial, very important for us to understand how the manipulation is being done. That is what? Prime numbers. Because the encryption was the secret key we use of prime numbers to generate those values. We use a very big prime numbers, 2 big prime numbers. When we multiply them together, it will be very difficult for an attacker or anybody to think of those 2 numbers in terms of factorizing them. So now, I said all these numbers, they can divide this. But now I want to try to explain some divisibility rules. Like for instance, if a number is given to me, how will I know that that number is divisible by 2? So once the number ends with any of this, it's 0, 2, 4, 6, 8. If we have any of this to be the end number, so automatically that number is divisible by 2. If any of this is the number that ends a particular number, so just conclude that this number is divisible by 2. So if I have a number like this, 1, 0, 4, 8, and I was asked, is this number divisible by 2? The answer should be what? Yes, because it's one of these that ends the number. So let me just move to what? 3 also. So how will I know that what? A particular number is divisible by what? By 3. For instance, let's say I have this 12, for instance. If I want to know whether this number is divisible by 3, once the sum of the digits result to a multiples of 3, that tells us that what? That number is divisible by 3. So I might be using some language that what? It might not be what? Conversant with. But pardon me, I will try to explain in a layman way. So what I mean is that for this number that we are looking at is 12, right? So those two numbers that we have in there is what? 1 and 2. So I want to confirm whether 3 can divide this number. So those numbers that is found here, we are going to add them together. If it results to multiples of 3, what I mean by multiple is what? Number that we get as a result of we adding 3 to itself continuously. Like if I start with 3, so that means 3 is what? Multiples of what? 3. So if I add another 3 to 3, what will it give? 6. Another 3 to 6, 9, comma, dot, dot, dot. So this one, you are forming a what? A sequence like this. So this one, this sequence is actually what? Multiples of 3. Because there are numbers that what 3 can divide. Or we can say what? It's just what number that we get as a result of it was accumulating what 3 to itself. Do we get that? That is what multiples. But I want to explain how to what? To know that what? This number is divided by 3, right? So those two numbers that is present here is what? 1 and 2. So the number that is present in this given number, we are going to add it together. Once the result is what? Is a multiple of 3. That makes what? That number was divided by 3. So I will need to add these two numbers together. 1 plus 2. Those are the two numbers present here. So if I should add 1 plus 2, what will it result to? Give us what? 3. So is 3 a multiple of 3? Yes. That means this number is divisible by what? By 3. Meaning 3 can divide this number. Please, do we get that? Now, if I have, for instance, I have 5, 1, 2. Now, I want to ask a question now. Let's say we have that. Is this number what divisible by what? By 3? 5, 1, 2. We have our answer be yes or no? No, in what sense? Can you tell me a reason why it is no? Exactly. But now, if you look at this, 108. Is 108 divisible by 3? Yeah, it is. Because the summation of the entire word digit result to what? 9. And 9 is a multiple of 3. So that is that for that. So we also have some other rules for all other numbers. So I just like to explain that of what 2 and 3. So that explains divisibility as a property or relationship. We are talking about a number theorem. We also have prime numbers. Now, what are what prime numbers? What are prime numbers? So what? Okay, number divided by 1 and itself, meaning you only have 2 divisors. So, and the 2 divisor is what? The number itself and 1. So, we can give what examples of such numbers. So, example of such numbers. Example of prime numbers now. We have them to be. So, what will it be? It will be what? 2, 3, 5, 7, 11, 13, 17, 19, comma, dot, dot, dot. Just to mention few. By the way, 9 is not there. Now, looking at all these, they are prime numbers. Why? Why are they what prime numbers? From the definition, prime number must always have what 2 numbers to be what divisor, meaning they are divisible by what 2 numbers. That is what the number itself and 1. So all that number cannot what divide what such number except 2 numbers. That is what the number and 1. Now, why is it that what 1 is not a prime number?
Because it does not have 2 divisors.
Exactly. So we are just trying to look at some of the properties and the relationship that we have in the definition of our number theorem. So property like divisibility, prime numbers, prime factorization, and so on, based on what I've shown earlier. And let me back it. So this property is what I'm talking about. So all these properties, divisibility, prime numbers, prime factorization. So we have greatest common divisor. Greatest common divisor is what we know already. That is our ACF, highest common factor, that we are familiar with. Just that you can also call it this particular name. So we also have LCM, ACFI. Greatest common divisor is the same thing as ACF, highest common factor. So, and modular arithmetic is part of what we are going to consider later on. So, after it will be covered under number theorem, is a concept to be looked into. So, congruence relationship also is used in modular arithmetic. So, number theoretic word function. So now, where we stop, we actually stop in binary numbers, because we look at number base. We know that this number base has to do with numeration system, or we say what numeral word system. So, and this word system can be in different base. We can have a number in base 2, base 3, base 4, and so on. So we try to point out some common word base. So like talking about a number in base 10. So number in base 10 is known as decimal, or we call it dinary. And a number in base 2 is what we call binary. And a number in base 8 is octal, while a number in base 16 is hexadecimal. We are trying to look at those ones that has more significant word application to what we are doing, or what we are about to do. So we could have in some other word base like 3, 4. They also have their own special name. So that is that for that. So we are going to continue from where we stop. We've already looked at how to, because we try to consider binary numbers, meaning number in what? In binary system. And in this system of numbers, we get to know that what? We only have 2 numbers in such system. The word bi means what? 2. So the only word numbers we have in binary system, there are 2, which are what? 0 and 1. So for instance, if we say what base 2, for instance, a number in base 2, so we should know that we only have numbers less than that word base number in that system. So if we want to talk about the set of numbers or the range of numbers in that system, it's going to range from 0 down to that particular word base number -1. So if I say it's going to range from 0, now it's going to range from 0 down to the base number. Let's say we have a number in base m, for instance, a number in base m. So the number we are going to have in this system that we have in base m is going to range from 0 down to m-1. So if we have a number in base 2, for instance, a number in base 2 now, so that means those range of numbers that we are going to have will be what? 0, 1. If it is what? Base 3, for instance, base 3. So the number we are going to have will be what? 0, 1, 2. So it's going to range from 0 down to 2. So I believe we understand that.